So this is going to be our lesson on linear inequalities, which is exactly the same as graphing a linear equation, except instead you're going to have one of these symbols. And so we're going to write what each of them means in these boxes. So this is less than or equal to. When you have the equal to on it, you're going to have a solid line. And that's like back when we were graphing just inequalities, and we had a filled in circle. And when we didn't have the equal to, we had an open circle. It's kind of the same thing. You're going to have a solid line or a dotted line. Or some people will call it an open line to relate it to the open circle. But either one, if it's less than or equal to, you're going to shade in below the line. Which should make sense because less than or less than equal to. And then these two, it's the same thing. If you have the equal to on it, it's going to be a solid line. If you don't have that, it's going to be a dotted line. So you just have to remember what kind of line to put. And if it's greater than or equal to, you're going to shade above the line. And we're going to use our calculator a good bit for this as well, because Desmos will actually graph these. And I'm just bringing up Desmos in another screen here so I can share my screen and show you. So we're going to graph this and then determine which ordered pairs are part of the solution set. So what I'm going to do is share my screen, and I'm going to put that inequality in here. So 3x plus y is greater than or equal to 6. And you can just type the greater than symbol and then the equal sign, and it'll give you that. Or you can open the keyboard down here to find that symbol. But I just need some pretty points to plot on here. So it's starting at 0, 6. Looks like it goes down 3 over 1, down 3 over 1. Solid line because of the equal to. And we're shading this side of it. So I'm just going to go ahead and put that on my paper. 5, 6. So right up at the top, it was down 3 over 1. So I'm just going to put in some points. Solid line. And we're shading above it. So what that means is all of these points are part of the answer. All of these points are not part of the answer. Since it's a solid line, the points on the line count. So if it's solid, those points count. If it's dotted, they wouldn't count, but we can count the points on the line. So we're just going to see which of these fall in the solution set. So 4, 3, 1, 2, 3, 4, 1, 2, 3. That's right here. That's in the shaded part. So we do want that one. -2, 4 would be right here. That is not in the shaded parts. We don't want that one. It's just like yes, no for each of these. 4, 5, 1, 2, 3. So -5, -3 is right there. That's not in part of the shaded part. And then 3, -3, that's this point that's on the line. It does count because the line is solid. If it was dotted, it wouldn't count. All right, we're gonna do the same thing for this one. Now, you can type this in the calculator, but this one's kind of like y equals mx plus b format. So I'm gonna graph it without the calculator. You're gonna start at -2. And there's nothing written in front of the x, so we know it's a 1. Your slope is 1. You're gonna go up 1 over 1. And we want a dotted line because it doesn't have the equal to on it. So what that means is these points on the line don't count. So on the line doesn't count. And it says less than, so we want to shade below. Again, you can use your calculator and type it in. It'll show you this. It's just that one was kind of set up in a good format, so I didn't really need the calculator. And then we're just going to check each of these points. So 5, 3 is on the line, but that doesn't count since it's dotted. 4, -1 would be right here. That's in the shaded part. We do want that. 0, 1 is right here. That is not in the shaded part. And 6, 0 is right here. That is in the shaded part. So we do want that one. All right. And we're just going to try this a few more times. We're going to graph them. State one point that's part of the solution. Now this one looks like y equals mx plus b. So I don't really need the calculator for that. Of course, you can use it. We're going to go up 6. And the slope is 2. So you would go up 2 over 1. That's going to put us off the grid. So instead, I'm going to go this way. You're just going down to left 1. It would be a solid line because of the equal to. and it says less than or equal to, so we want to shade below it. And again, you could use the calculator, and it'll show you exactly what that looks like. So state one point that's part of the solution. I'm going to pick the origin. The origin is part of the shaded part. But of course, any point over here or any point on the line would count. All right, this one's not really set up in y equals mx plus b format, so I'm going to go ahead and type that one in the calculator. So it is x minus 2y less than 4. So I just need to find some pretty points to put on here. It's starting at 0, -2, and it looks like the slope is a half. It's going up 1 over 2. So we're going to start down 2 and then do our slope of a half. And it was a dotted line. And here, let me go back to it. I forget where it was shaded at this point. Dotted line, and it's shaded above it. So state one point that's part of the answer. I'm going to pick 0, 4. But any points over here would count. Points on the line would not count because it's dotted, so those wouldn't count. Now this is like x equals, if you think back to your Hoy Vux, it's going to be a vertical line at 2, and it's going to be dotted because we don't have the equal to. So vertical line at 2, and it says less than. So no, you don't really have an above and below for a vertical line, but less than would be to the left. It's going to be this side. And you can, of course, type that in the calculator too, and here I'll show you. So if you type x less than 2, it'll show you the dotted line at 2, and it's shaded to the left side. All right, and then pick a point that's part of the solution. I'm going to pick -2, 3. Again, any point that's over here counts. Right, points on the line would not count since it's dotted. All right, and then we have some word problems. Tickets for a school play are $5 per student. We're going to make student be X, $6 per adult. I'm going to make adult be Y. They want to earn at least $3,000. That means they want to earn 3,000 or more. All right, they want at least 3,000. So we would have 5X plus 6y, and just instead of equals 3,000, we want to be greater than or equal to 3,000. Want 3,000 or more. So we're going to graph it and label. So down here, x was student and y was adult. And I'm going to type this into the calculator. I'm gonna have to zoom out a good bit because it was all the way up to 3,000. All right, but solid line because we have the equal to, and it's shaded above. So it looks like it's starting at 500. And then down here on the x-axis is at 600. So I'm gonna go ahead and plot those. So we've got 500. And then down here was 600. So it's down 5 over 6. Is our slope, and then we're going to shade above it. So if 200 adult tickets are sold, and again, adult was Y, what is the minimum number of student tickets that must be sold? We're going to take 200, plug it in for Y. Oops, I drew my arrows on the wrong one. We're going to plug that in for Y and then solve it for X and see what we get. So that would give us 5X plus 6 times 200 would be 1,200. And then we just solve the inequality. So what is that going to give us? 1,800. And then divide by 5. Let me go ahead and type that in. Right, and I got 360. So they need to sell at least 360 student tickets to make the amount of money that they want to make. All right, so last one, you have $9. Apple pies are $3 each. So we're going to make apple pie be X, pumpkin is going to be Y. And so we're going to write our inequality. Now you only have $9, so you can't spend more than what you have. So you're gonna have to stay below or equal to $9. This is gonna be less than or equal to, because you can't spend like $10 if all you have is 9. All right, so we'll have 3x plus, pumpkin pie is $1, so 1y or just y, you can put the 1 there if you want, has to be less than or equal to 9. So I'm going to share my screen and we'll go and type that in. So 3x plus 1y is less than or equal to, less than or equal to 9. I'm gonna hit the home button to put this back in the center. So it's gonna start at 9. And our slope is down 3 over 1, down 3 over 1, down 3 over 1. It's going to end at 3 there. All right, so we're going to start at 9, down 3 over 1. Now you only have $9, so you have to stay below that. Now you also can't have negative money, so I didn't shade all the way over to there. It's kind of staying in this triangle here because you don't have, you can't have negative pies, I suppose. And apple was X and pumpkin was Y. All right, so we graphed, we labeled. So what are some combinations of pies that you could buy? Well, that's going to be where all these points end up. So you can buy 0 apple and 9 pumpkin. Because if they're $1 each and you have $9, you could just buy all pumpkin pies. You could buy 1 apple pie and 6 pumpkin. So that's $3 for an apple pie. So you have $6 left over, and those are $1 each, so 6 pumpkin. You can buy 2 apple pies and 3 pumpkin pies. Or you could buy all apples. So you can get 3 apple pies and 0 pumpkin pies. Now that's assuming they don't sell like half of a pie, which they probably don't. It would be like a whole pie. Now I'm just going to do one delta math problem so that you can see how this works, what buttons to hit. All right, so we've got x minus y less than -1. So let me go over to the calculator. Gosh, I can't see here. All right, x minus y less than -1. So I've got that typed in. So it's starting at 0, 1, and the slope is 1, up 1 over 1. So I'm going to go back to my delta math. We're going to start at 1 and do a slope of 1, up 1 over 1. Now you have these two buttons, change line or change shade. So if you look at the calculator, it is a dotted line. So we will have to change that, and it's shaded above. So I'm going to change the line. See if you toggle between those. We want it dotted and change shade. I do want it on this side, but like if you just hit that button, it'll change it for you. So we want it shaded above. We're going to hit submit, and it's going to tell us we're correct.